All right, so we're trying to talk about the base of a solid today. So this is 6.2. What does it say at the top of your notes? Just 6.2 continued or something? Like last section or something like that? Yeah. So it's 6.2 continued. I think it's like your last topic, right?
Oh my gosh.
That's kind of exciting.
How do I make myself? I'm so interested.
We're recording right now. We're recording. Yes, you could. You could grab the podium. So find the solid whose base is bounded by these two equations. You can use the podium. We got this equation, we got this equation, and I think on your notes I have a graph that kind of shows that. So I'm going to split the screen now. This is the graph of those two equations, and I think you've actually seen these if you did the circuit training. You've seen these equations, so you kind of have a pretty good familiarity with them. We want cross sections that are the height, they're rectangles. I want these rectangles that are in this area. So I'm going to, basically what I'm saying is, let me try to put this as clear as I can. I want to know if I was to take this right here, I'm going to make this really bold, okay? So maybe you should do the same. Okay, that line right there, I'm going to take that line and I'm going to copy it. And I'm going to bring it down, oops, that didn't work. I'm going to clone it, rather. And I'm going to bring it over here. And I'm going to rotate it, okay? Rotate it, okay. So that is that segment. Does everybody see that? What did we say about this thing? We said they're rectangles, right? Rectangles with a height double that of its base. So my first question is, how long is this green line, this green inchworm line thing, whatever you want to call it? How do you find the length of that green segment? What do we say all the time? What have we been saying about these things? What's that? No, when we're doing the spheres, what do we always do? Top minus bottom. Top minus bottom? Yes? Why don't you say that a couple times? Top minus bottom. Yes? Top minus bottom. Good. If we weren't recording, I'm sure you could say it. Okay, so we're going to take top minus bottom. Okay? So that's how we're going to figure out the green length. So can somebody tell me what's on top? Okay, perfect. No, because x squared is this one. This is x squared, right? Yeah. 4x minus x squared. Top minus bottom. That is the length of the green line. That's the length of this green line. So this green line has that length. So therefore, this green line has the length of what? The same, right? So 4x, I'm going to simplify, minus 2x squared. All right? What I want you to understand is, remember how I had taped index cards to the board and they were popping out at you? Yes? Okay. So what's going to happen is we're going to have a rectangle that's coming out of the page like this. It's going to come like this. So I'm going to draw the rest of that rectangle now. And what did they say about the height of the rectangle? What did they say about it? Somebody? Anybody?
Double.
Double. It's double what?
Times.
Double the base, right? Yeah, double the base. So it's the base times 2. So what is the base right now? How wide is the base of this thing? 4x minus 2x squared. So we need to double that. So I'm just going to make it 8x minus 4x squared. I just doubled it. Okay? All right, so that is one of those index cards that's popping out at you. Out of the screen, popping out towards you, there is this shape right here that looks like this building, I guess you could say. This shape right here, okay? So that's what's coming out towards you. And what you want to know is the area of that. So we're going to take a minute and just find the area of that. What is the area of this rectangle? Well, how do you find the area of any rectangle? Yeah, area is base times height. So we're going to take the base, which is 4x minus 2x squared. We're going to multiply it by the height, which is 8x minus 4x squared. And that's going to be the area of this thing. That's the blue area, okay? So that's this area. Now, remember, if you take a whole bunch of index cards and stack them, or you take a whole bunch of pieces of paper and stack them, what do you eventually get? Do you have area or volume if you stack a bunch of areas? Right. So if you integrate area, if you sum up, if you add up a bunch of little bars, you get area under the curve. But if you add up a bunch of squares, you're actually going to get volume inside of a shape, I guess, not necessarily under the curve, right? So we're going to need to integrate area, integrate the area. When are we going to start integrating the area, and when are we going to stop integrating the area? So at what point do we start making these index cards, and at what point do we stop?
0 to 4.
0 to 2, yep, and 0 to 2 because we're going this way, you know. So 0 to 2. There is no pi, there's no circles. We're not doing this with circles, we're doing this with just rectangles. So instead of integrating circles, which are always pi r squared, we're just going to integrate the area of that shape I did on the first page. And that area is this. So I'm going to actually just replace this with that whole mess. You eventually will have to FOIL it out and all that stuff, or you can just put it in your calculator. But this is what we have to integrate. If we integrate that area, if we integrate this with respect to x, dx, right? That is going to be the area of the solid with all of these things sticking out. I'm going to do my best to imagine these popping out of the screen in 3D. There's like a card here. This is where you're really going to see my artistic ability shine through. Okay? There's like another card here that pops out, right? And then here we have another one that's coming out of the screen. These are all coming out towards you. I know it's very clear by my drawing that that's happening. You know, you got another one here that's coming out. So there's all these rectangles that are kind of like popping out of the screen towards you right now. That make sense? If you integrate all those rectangles, if you add up the areas of all those rectangles, if you sum all the areas of those rectangles, and this looks like an S for sum, if we sum all of the rectangles, we'll get the volume of this shape, and it's going to look like a piece of modern art. It's going to look very weird. So that's basically where we're at. So visually, what does that look like? So let's see where we are here. I'm going to show you what that looks like visually. Let's take a second. Base of a solid Wolfram demo. We'll leave that.
Can I go to the bathroom super quick?
Yeah. So what do these things look like? Well, that's the question. That's a huge thing. If you can't visualize it, you're going to have trouble. One of the biggest things that I can recommend is to draw the shape that you're going to be integrating. If it's a square, draw a square and figure out the area. If it's a triangle, draw a triangle and figure out the area. If it's a semicircle, draw a semicircle and figure out the area, right? They're all going to be variabilized areas, and then you're just going to integrate those areas. So here's what some of these things look like, just a general ballpark of what they look like. So here's one of them. You can see that it's basically, we're taking this distance right here, we're taking this to here, you can only see the mouse on the video, and this is going to pop out and make a square. So it's a circle in the base, right? And the cross sections that come up are squares. So you can see if you do that, you get something that looks something like this. But now if you were to take, let's say you were to take a triangle, and you were to have semicircles pop out of it. Well, if you took a triangle, you almost have like a crescent roll now. You see that? It almost looks like a crescent roll. This is a triangle, but there's all these semicircle arches, golden arches, we could say, coming out towards us. So we have this awkward-looking thing. It's flat on the top, the bottom. It's flat on the bottom. It's that shape that we're looking at. There's the shape that we're looking at. But what I'm recommending you do is to draw these semicircles. I'm having a hard time manipulating this. Draw these semicircles that are coming up so that you can have a pretty good idea of what they look like. But there's a ton of semicircles, and together it looks like a crescent roll when that happens. And this can happen for a lot of different things. We could have a square with triangles coming out of it. Well, that's actually not that bad, because that's actually a normal triangular prism. That's a square with a whole bunch of triangles. Here's a circle with a whole bunch of triangles. That looks a little weirder. And that's basically what's happening with this section. So that's kind of what we're trying to do here. Let's see if we can go on a little bit more.